here we have a section on angles, and just to quickly review, there are three parts to the angle. There's the initial side, where you're going to start, the vertex, where the two sides meet, and the terminal side, where you're going to stop measuring the angle. So this angle would be measured from the initial side to the terminal side. Now when you want to measure, you're just going to grab your protractor, set it up so that the middle is right there on the vertex, and then you're just going to follow along and just read right up. So here, this angle, 41 degrees. Now, there's a standard position for how angles are usually written. So we start with the initial side right along that x-axis. So that's your initial side. The vertex would be then at the origin where the x and y-axis meet. We always set that up. And now your terminal side can be anywhere that you're going to measure that angle. So, for example, this first angle here, measuring from the x-axis up to the line. Since we're going counterclockwise, this is a positive angle. However, the second angle, if we went the reverse order, when we went clockwise, this is called a negative angle. So that's just a note on how to write properly angles. So, often angles are described within whichever coordinate section they're in. So if we do a first angle starting on the x-axis and going up to about here, that's a first quadrant angle. Same, an angle that went to the second quadrant, third quadrant, fourth quadrant. So whichever way, either if a positive or a negative angle, either way, we can describe it between which quadrant it is in. Just some terminology now. A quadrant angle just means that the terminal side is on one of the axes. So a 90-degree angle is a quadrant angle. A negative 90-degree angle is a quadrant angle. Anything where it touches either the x or the y coordinate in its terminal side, we know that's a quadrant angle. Finally, coterminal angles. Coterminal angles are any angle which give the exact same graph, but there may be different ways to write them mathematically. So, for example, here we have an angle of 43 degrees, and we've just gone right from the x-axis up to the angle. But we could also write it like this, as a negative angle of negative 317 degrees. These are coterminal angles because they're both in the exact same position on the graph, and yet they're written in different ways. Another way that we could do this, for example, would be to have an angle that goes around, and this would be 403 degrees. But we could also have written that as 43 plus one loop times 360 degrees of that loop. So those are the same definitions. So we have this nice formula where theta plus any integer for n times 360 will give a coterminal angle for the original theta angle.